So this entire time we've been talking about F inverse, does it exist, does it not exist, how can we restrict domain so that it does exist, but we haven't actually said how do you find it. So that's what this one is. This is how to find F inverse. So we're just going to go through a step-by-step process. First thing you want to do is ask yourself, does it actually exist? You don't want to go trying to find something that doesn't exist, so you got to make sure that f of x is 1 to 1 or it passes the horizontal line test. You might have to restrict the domain. So you might have to restrict the domain. And that's in the last video. If you have to restrict the domain, just restrict it so that now you have a function that's 1 to 1 or it passes the horizontal line test. Next, you're going to set y equal to f of x. So just take your function and set it equal to y. Third step, you're going to swap x and y. So everywhere you see a y, write an x. Everywhere that you see an x, write a y. Next, solve for y. This step is going to be the hardest, so we're going to pay very special attention to step 4. And number 5, whatever you get in step 4 is your inverse. One thing I do want you to recall is that the domain of f is the range of your inverse, and the range of f is the domain of your inverse. So let's just do a couple examples. I think we're going to do 4 examples. We want to find f inverse. We want to restrict the domain if we have to. So restrict domain if we have to. We're going to find f inverse and then give the domain of the inverse and the range of the inverse. That's going to be our goal. First one that we're going to do. Let's let our function be 2x minus 1. Our goal is to find f inverse. We also want to find the domain and range of the inverse. So let's start with step 1. Is this function 1 to 1? Let's just real quickly here draw a picture. This is a line with y-intercept -1. So this is my function. Is this function 1 to 1, or does it pass the horizontal line test? Yes, it does. What that means for us is that we don't need to restrict the domain. Let's go ahead and write out what's the domain of my function. Well, if you remember when we were doing domain, this is not dividing by anything that's 0, there's no even roots. So the domain is all real numbers. What's the range of my function? Well, look at your graph. The range is all the possible y values. You can see that since the graph goes kind of down forever and up forever, I can get any possible y value. So my range is all real numbers again. Okay, so we've checked to see that it does pass the horizontal line test. That means f inverse does exist, so let's begin the process. First step, I should say second step on that list. Let's set y equal to f of x. So y is 2x minus 1. Next, switch your x's and y's. So I'll get x is 2y minus 1. Now I solve for y. This is again going to be kind of the hardest part. I'm going to move this 1 over to the other side. So x plus 1 is 2y. And then divide both sides by 2. So y is x plus 1 over 2. So that's your inverse. If inverse of x is going to be x plus 1 over 2. Now what's the domain of f inverse? Well, we've already done that work. That would be the range up here. So that's all real numbers. And what's the range of f inverse? That's the domain of f, so also all real numbers. So this would be your answer. Now it is important to kind of take a side note here and to ask the question, what is f of f inverse of x? Also, what is f inverse of f of x? Let's think about f of f inverse of x. f of f inverse of x, that means do the function, the inverse of f, and then do f. So it's kind of like I'm undoing what I've already done. So if you think about our picture here, this was the domain of f, here's the range of f, here's my x, here's my y. F took me here, f inverse took me back. So this is saying start with f inverse. So I'm starting over here and I go back to x. Now I do f, and I'm back to where I started. What's my other one? F inverse of f of x. So it says I start here, I do the function f, then I undo it, so I'm back at x. So this is true of any inverse. If you do the inverse and then apply your function, you're back to x, and then if I apply my function and then apply the inverse, I'm also back to x. So this is kind of important. If I compose these two functions, so 2x minus 1 and x plus 1 over 2, I better get x. So the composition of f and its inverse should give you just x, which makes sense because f is like a machine, gives you the output, then f inverse undoes that. So I should get back to where I started. So that's why these both should give you x. Okay, continuing with our examples, we do 3 more. Our second example is going to be f of x, x over x minus 1. First thing we want to do, decide does the inverse actually exist? So let's just make a sketch of the graph. We're going to do this kind of upper part, this lower part. I have a vertical asymptote, draw it very well, at 1. Here's my x, here's my y. Does this pass the horizontal line test? And the answer there is yes, it does. So the inverse does exist. What's the domain of this function? So the domain of this function is everything except for 1. So that would be negative infinity to 1 together with 1 to infinity. And then what's the range of this function? Well, let's see. What y values can I get out? Well, I can get any y value except for this here at 1. And you can see this if you plot this on your calculator. So I can get any value except for 1 as my y value, so that's my range. Okay, let's go ahead and find the domain then. So we know it passes the horizontal line test. Let's find the domain. First step, set y equal to f of x. Next, switch your x and y. So I have y over y minus 1. Now let's solve for y. Well, I have y in the denominator, and that's always going to be a problem, so let's multiply both sides by y minus 1 to get this out of the denominator. So I get x times x minus 1 is equal to y. And now let's go ahead and distribute that x. So I have xy minus x is equal to y. Okay, what's the problem here? Why can't I just easily solve for y? Well, the problem is that I have y on both sides of the equals. So what I can do is put everything with a y on one side, everything else on the other. So I'm going to move this y to the other side and move this negative x over there. So I'll get xy minus y is just x. So why did I do that? Why did I move everything with a y to one side and everything else to the other? Because now I can factor out a y. By factoring out this y, I can divide both sides by x minus 1 and solve for y. So this is my inverse. Now it's interesting that this is the same function, that f is its own inverse, but that's okay. There's my inverse. What's the domain of my inverse? Well, that was the range of my original function, so negative infinity to 1 together with 1 to infinity. And what's my range of the inverse? That's the domain of my original function, so that's negative infinity to 1 together with 1 to infinity. So the important step in that problem was realizing that if you want to solve for y, and you have y on two sides of the equation, put everything with y on one side, move everything else to the other. Let's do a third example. How about f of x is 2 over x minus 1? First question to ask yourself, does f inverse exist? Well, let's see if we draw the picture. This one has a vertical asymptote at 1 and looks like this. And again, you can use your calculator to plot these functions. You don't have to necessarily just know what they look like. Does this function pass the horizontal line test? Yes, it does. What's the domain of my function? Let's see, here my domain is everything except for 1. I can plug in any x except for 1. So negative infinity to 1 together with 1 to infinity. You could also do this by hand, draw your number line, mark off 1 because it's in the denominator, see what's left over. Now what's my range? So the range is what y values can I get? So can I get any y value? No, this never crosses the x-axis, and that's where y is equal to 0. So I can't have 0. Okay, so I have my function. It is 1 to 1. So now let's go ahead and find the inverse. Step 1, set y equal to f of x. Next, switch my x and y. Now I need to solve for y. Problem is y is in the denominator, so let's multiply both sides by that denominator. So x times y minus 1 is equal to 2. You have a couple options here. You could either divide by x or you could distribute the x. Let's go ahead and just divide by x. So I'll get y minus 1 is 2 over x. And then lastly, let's add 1. And that gives me my inverse. So my inverse is going to be 2 over x plus 1. What's the domain of my inverse? That's going to be the range of my original function, so that's negative infinity to 0 together with 0 to infinity, which makes sense. What's the domain of this function? Well, I can't plug in 0 because I have a denominator, so it makes sense that I can't plug in 0 for my domain. And then what about my range? That's going to be the domain of my original function. So negative infinity to 1 together with 1 to infinity. Okay, and let's do one more. How about f of x is x squared? Again, first thing to ask ourselves, is this 1 to 1? Does it pass the horizontal line test? Here's x squared, here's x, here's y. Does this pass the horizontal line test? Definitely not. So this is not invertible as it is, but let's go ahead and restrict the domain. So what if I just get rid of this right-hand side? Now what's my new domain? If I make my new domain negative infinity to 0, now this is invertible. So if I only include the left-hand side, it does pass the horizontal line test, so I can find the inverse. What's the range of this function? So what y values can I get? The smallest y value is 0, and then it goes on forever. So 0 to infinity. Okay, now let's find the inverse. So by restricting the domain, it is invertible. So my first step, set y equal to f of x. Next, switch x and y. Now solve for y. So how do I solve for y? I take the square root. Now the problem is there are two square roots. There's the plus or the minus. The question is, which one are we going to take? Well, if you remember, this domain up here, that's going to give me the range of my inverse, which means that everything that I put into my inverse better give me something negative out, because this is the range of it. So here I want to take the negative square root. And again, that's because my range of my inverse is this, the domain of my original function. These are only negative numbers. So that means that whatever I plug into my inverse, I better get out something that's negative, so I have to be the negative square root. So my inverse function is negative square root of x. The domain of my inverse, that's the range of my original function, so 0 to infinity. And the range of my inverse is negative infinity to 0, because that was the domain of my original function.